Hi everyone, in this video I'm going to discuss about the solid principle. So S stand for single responsibility, O for open close principle, L for Lisco substitution principle, I for interface segregation principle, D for dependency inversion principle. So we will see here interface segregation principle, right? So we can see this picture. What we can say that the interface segregation principle say that the client should not be forced to depend upon interface that they do not use. So what is meaning of that? So any of the class where we are inheriting the interface, okay, we should not force right to the client or class, right? Because whenever we will inherit any of the interface into our class, right, in Delphi, we need to implement all the method of the interface in class, right? So suppose in a interface, suppose we have a five method, okay, and when we are inheriting the interface in our class, we actually need only three method out of five of the interface, right? But here, when any of the interface we will inherit in our class, right, we need to implement each and every method that is available in the interface. So that is what it's saying in the interface segregation principle. Clients should not be forced to depend upon the interface that they do not use it. So we should not force that interface, right? That where the five method is there, and our class is inheriting that method, that interface, and we should not force our class to implement all the five method. So instead of such kind of interface, right, fat interface or bulky interface, we should have the small interface and multiple interface. So suppose we can have out of the one interface, right, with the five method, we can have one interface with the three method and other interface with the two method, right? So as per our requirement, whenever our class try to inherit any of the interface and all the interface functionality, all the interface method, right, that we want to consume and we want to give the definition, that will be meaningful. Okay. So we should not force to our class to implement the interface, right? Where a lot of method is there that is not usable to the class or that logic. We don't use that method, right? So that is called the interface segregation principle. Let's take one example here. So just I have created one I-shape interface, okay, and the two method I have created here, the area and circumference, okay. Now here is my square class and I'm inheriting the I-shape interface. This interface I'm inheriting in my class square. What will happen? I need to give the area and circumference function, right, to our square method, right? We have to write it, we have to define it. The next is the T circle class is there. Here also I'm inheriting the I-shape. Why I'm inheriting the I-shape? Because I need that the area, okay, and circumference. So in this circle class also I need to give the definition of these two method, area and circumference, right? So what will happen if you see that here in T square, right? I'm inheriting the I shape interface and this is the square. So what is this class is going to do? This is the square class, okay? It will it will give return the area, right? But a square cannot have the circumference. So when I'm inheriting the I shape, right, in my class is T square, obviously I have to give the definition of the circumference, right? So we need to raise the exception here. Circumference is not possible in the t square, right? Or circumference is not possible in the square. Fine. But if you see that the same situation, right? In the circle, we are inheriting the I shape where area and circumference both are fine for circle, right? But in the square, this I shape interface is right not perfect, right? So what we need to do, so that is what we can say that this is not the interface segregation principle following here, right? Because we are forcing in a T square class, right, to I shape interface to implement each and every method of the I shape. where the circumference method is not required in the t square class. That's not relevant at all. Let's take here. So what we need to do it to follow the interface segregation principle. I say area one interface I have created, okay, and where this is the one of the area method only in this method in this interface, right? Again, I have created one more interface I circle shape, and I'm inheriting the I shape area. Okay, this I shape area into the this interface, and here I have given the area is the one of the method and circumference is the other method. So now it's clear for us. Okay, whenever I will inherit the I shape area, right? I can inherit the I shape area in my square t square class. Fine, because I need only the area, and we can calculate only the area of the square. But whenever the circle class, I need the area and circumference both, right? So in case of the circle class, I can inherit the I circle interface, and that I circle interface is the area and circumference method is there. So this is fine for me, right? Because I need these two method. I can implement these two method. I'm not forcing anything to these classes, either T square or T circle class, where any of the like interface, we need to implement it. In the interface method, we need to implement forcefully, right? So this is what the segregation principles. We will see this one in the Delphi. So here I have created the interface segregation principle, right? The one class T shape, same thing here, and this is the T square class where I'm inheriting the I shape, and T circle class where I'm inheriting the I shape again, right? So we know that in the T square, right? We don't need the circumference because the square don't have circumference. But because we are inheriting the I shape interface in my T square class, that's why we need to write this method into the this class, and we have to give the definition also. Right. The next is the circle here. So I shape again in I shape interface I'm inheriting here. So I need to give the area and circumference method because my I shape have the area and circumference method, right? So what are the method will be available in the ISAFE? We have, if you are inheriting the interface in any of the class, we have to write all those method into our class also and give the definition of that method. Okay, we can write the logic. So what I'm doing to do just simply I'm just writing the like returning the area here. Okay, in case of the square. Okay, and the circumference. What I'm doing, I'm just writing the right exception because circumference we cannot right calculate for the square. So that's why I'm raising the exception. The circumference cannot calculate it for the square. But for the circle, everything is fine. Like area and circumference, we can calculate it. So area will be right pi r square, okay, and circumference will be 2 pi r, right? So here the calculation is there, and after that on the button click right on the form create, I'm just creating the object of these two classes, trying to access the method right here, and here I'm creating the square class object, okay, and assigning the value to the width and right and depth, width and length, and after that I'm just calling these two method area and circumference. So let's so we can see that the area of the circle is right this much, and some circumference we can see that right here we are trying to get the circumference right of the circle, okay. So F9, yeah, so calculation is there, and then again we are trying to uh, create the object of the t square assigned to the object t square variable of t square class, right? And then we are calling the method object square dot area, so we will get the area, right? And then so message again I'm just object square dot circumference. So square we can't have the circumference, so what it will do, it will go and raise the exception here, okay, right? Square dot square class circumference method. So just it will raise it, okay, it will show the message, right? Exception message. So this is all about the right the interface segregation method where the violation, right? We are violating that. We are forcing the square method, square class, to implement the T-shape, right, interface, and these two methods we have to implement it, right? So, but the square don't need the circumference method, right? Because square circumference we cannot calculate for the square, but for the circle we can calculate the area and circumference. So that's fine. But here we are forcing our client, right? We can say that we are forcing our client to implement the fat interface that is not required. Okay. So, how to overcome with this? So, I have created here this the separate application, right? Interface segregation principle. So, what I did it same we have discussed earlier, right? The I shape area I have created where the only one method area will be there, and the circle shape, right? Where I'm inheriting this interface into my circle shape interface, and here now we have the area and circumference, and on the basis of the our requirement in the class, right? We can we can inherit the specific interface. So square we need it only the area. So what I will do, shape area I will inherit, but in my circle we need it, right? Area and circle. So I'll inherit this circle shape. Okay. And we can give the definition. So here we are not forcing any of the client to implement, right, on the interface that is not required, fine, or the method from the interface that is not required, right? And the same thing just given the definition and just calling it, right? But most important part is the interface segregation principle is we should not force, right, any class to implement any of the right interface where some of the interface method is not relevant to the particular class. Okay. So it will be better if you create the small interface like what we did it here, right? What we did it here, small interface, right? So that we can achieve the interface segregation principle.